Hi, welcome to YouWillUnderstandMath.com. Today I want you to understand how to derive the cosine and sine values on the unit circle. For example, here we have pi over 6, which is the same as 30 degrees. Cosine of pi over 6 is the square root of 3 over 2. Sine of pi over 6 is 1/2. The question is, how do we get these values? We will use special right triangles, but before I show you how to use them, let's review the sides of a right triangle. Suppose we have a right triangle like this, and we have angle A. This angle could be denoted by theta or any other letter or Greek letter. Moving across from the angle, we have the opposite side of the triangle. Moving across from the right angle, we have the hypotenuse. The remaining side is the adjacent side of the triangle. I'll use these terms each time in the triangles to follow. Here, you see we have the 45, 45, 90 degree triangle and a 30, 60, 90 degree triangle. The reason they have these names is because, for example, two angles in this triangle measure 45 degrees, and then there's the right angle, which is 90 degrees, hence the 45, 45, 90. Across from the 45 degree angle, we have the side of length x. Across from this 45 degree angle, we have the side of length x. Across from the right angle, we have the side of length x times the square root of 2. The 30, 60, 90 triangle also has special relationships between the sides. Across from the 30 degree angle, the smallest angle, we have the side length x. Across from the right angle, we have the side length 2x. Across from the 60 degree angle, we have x times the square root of 3. If I wanted to use terminology such as opposite, adjacent, and hypotenuse, I would be concerned with one angle. For example, if I were just focused on this 45 degree angle here, the opposite side of this triangle would be this x. If I wanted to know where the hypotenuse is, I would go across from the right angle, and this side would be x times the square root of 2. The remaining side is the adjacent side, which is this side here, which is also x in this case because of the 45 degree angles. It's an isosceles triangle, so these two sides are always equal. In this triangle, suppose I wanted to focus on the 60 degree angle here. In this case, the opposite side of the triangle will be x times the square root of 3. The hypotenuse would be 2x, which is across from the right angle. The remaining side would be x. If I were focusing on a 30 degree angle, the opposite side of this triangle would be x. The hypotenuse would still be 2x, and the adjacent side would be x times the square root of 3. Here I have a blank unit circle, except for the angle here, 30 degrees. I want to know what is the cosine of 30 degrees and what is the sine of 30 degrees. In order to figure that out, I've created a right triangle here. We have the 30 degree angle here, which means that the remaining angle must be 60 degrees here. You see that I have a 30, 60, 90 degree triangle. We know that opposite the 30 degree angle, the length of this leg of the triangle will be x. We know that the length of the side of the triangle across from the 60 degree angle will be x times the square root of 3. And we know that the hypotenuse, this light blue color here of the triangle, will be 2x. Because I know this is a unit circle, the hypotenuse must be 1 because it is a radius of the unit circle. Therefore, we have 2x equals 1 because the length of the hypotenuse is 2x, and it's also 1 because it is a radius of the unit circle. We can solve for x by dividing both sides by 2. We have x equals 1/2. That means that the shorter leg of our triangle, the opposite side from 30 degrees will be 1/2. Therefore, the height of this triangle is also 1/2, and we've just found the sine value of 30 degrees. The adjacent side here will be x times the square root of 3, whatever x is. Well, we know that x is 1/2. That means that this will be 1/2, and it's positive because it is the x value. We know that the x values in the first quadrant are positive. We'll have 1/2 times the square root of 3, which is the same as the square root of 3 over 2. We've just found the cosine value of 30 degrees. Sine of 30 degrees equals 1/2, and cosine of 30 degrees equals the square root of 3 over 2. I want to point out something important. The vertical height of this triangle was denoted by x. It represents the height of the triangle. Since we're in the first quadrant, this will be a positive value. That's why x equals positive 1/2. For example, if we created a triangle in the third quadrant, the vertical height of the triangle would be negative because the y values are negative in the third quadrant. You have to pay attention to those things when you're filling in the unit circle using special right triangles. X times the square root of 3 came out to be positive 1/2 times the square root of 3 because the x's are positive in the first and fourth quadrants actually. I have a new triangle that I've created in order to find the value of cosine and sine of 45 degrees. I've created my 45-degree angle here, and we want to know what is the cosine of 45 degrees and what is the sine of 45 degrees. Well, we know that the side opposite the 45-degree angle will be denoted by x. In the same way, we have another 45-degree angle here, which means that the side opposite this 45-degree angle, which is also the adjacent side of this 45-degree angle, will be x. The hypotenuse is this red line here in the first quadrant, and we know that that will be x times the square root of 2. Well, just as in the last example, we knew that the hypotenuse is 1 because it is a radius for the circle. So we have x times the square root of 2 equals 1. We can solve for x by dividing both sides by the square root of 2. We have x equals 1 over the square root of 2. But we don't like radicals in the denominator. We need to rationalize the denominator. We'll multiply top and bottom by the square root of 2, which gets us square root of 2 over 2. Because the square root of 2 times the square root of 2 is the square root of 4, which we know is just 2. We've just found x, which also happens to be the sine value because it is the vertical height of this triangle. And once again, it's positive because it's in the first quadrant, and we know that the y values are positive in the first quadrant. Sine of 45 degrees is 45 degrees because of this 45-degree angle here, will be the square root of 2 over 2. Well, because this is an isosceles triangle, meaning that two sides of the triangle are equal, this x is also the square root of 2 over 2, which means we've just found our cosine value, which is the distance from the origin to the edge of this triangle here. Cosine of 45 degrees is the square root of 2 over 2 as well. We've just found the sine and cosine values of 45 degrees. Suppose I wanted to find the cosine and sine of 210 degrees, or 7 pi over 6. How would I get these values, negative square root of 3 over 2 for cosine and negative 1/2 for sine? If you notice here, there's a reference angle of 30 degrees. The reference angle is the difference between the terminal side of the angle. For example, if we go from 0 all the way around to 210 degrees, the reference angle would be the difference between the terminal side, which would be here, at 210 degrees and the x-axis here. We can find that by subtracting. If we subtract 210 minus 180, we'll find that the reference angle is 30 degrees. Notice here I have a unit circle, and I've created a right triangle with the reference angle 30 degrees. If this angle is 30 degrees, that means that this angle is 60 degrees, because this one is 90 degrees. Every triangle must have angles whose sum is 180 degrees. We know that the side of the triangle, the right triangle, opposite the 30-degree angle will be x. But I have to be careful here. I'll label it x, but I know that my final answer should be negative because we're in a third quadrant. This vertical distance here should be negative because y values are negative in the third quadrant. I also know that the hypotenuse will be 2 times x, which is this light blue colored line here of the triangle in the third quadrant. The final side, the adjacent side, will be x times the square root of 3. This side will also be negative because we're to the left of the origin. Remember, we're still in the unit circle and we're to the left of the origin, so this value will also be negative. Okay, what do we know about this triangle? We know once again that the hypotenuse is 1 because this is one radius of the circle. We have 2x equals 1. Solving for x, dividing both sides by 2, we find that x equals 1/2. But once again, remember, this vertical distance is a negative value because it's in the third quadrant. That means that the sine value will be negative 1/2. Remember, our original problem was sine of 210 degrees, not sine of 30 degrees. We have sine of 210 degrees is negative 1/2, once again because sine is the vertical distance. We know that the vertical distance in the third quadrant should be negative. For cosine, we have x times the square root of 3, which will be 1/2 cosine of 210 degrees will be 1/2 times the square root of 3. Once again, we're in the third quadrant, we're to the left of the origin, so this should be negative. We can simplify this a little bit. We have negative square root of 3 over 2. We've just found the sine and cosine values of 210 degrees. Here you see in our unit circle, at 210 degrees, cosine is negative square root of 3 over 2, sine is negative 1/2. And once again, that is because we're in the third quadrant, so that the vertical distance should be negative, the horizontal distance should be negative as well for our triangle. If you notice, as we go around our unit circle, all of these can be found using a 30, 60, 90 degree triangle or a 45, 45, 90 degree triangle. Next video, I will show you how to use a shortcut in order to find all of the cosine and sine values on the unit circle. Please like and or subscribe to this video if you've enjoyed it.